this evening we're going to look at immersive audio, and we're going to look at it from the cinema to the home. So we'll be looking at the whole profile of that. Nick Engel has come along from Dolby in Sydney. I'll try and get out of the light. Should I be over there?
Should be near the microphone.
That's right, I should be near the microphone. Nick is going to discover the evolution of channel-based audio to immersive audio formats and how this shifts the paradigm of audio authoring, delivery and playback. He will describe immersive representations such as the object-based immersive or OBI systems, the channel-based immersive CBI, and the sound field formats, and cover key concepts and relevant ITUR and SMPTE and probably AES standards, maybe. Okay. Nick will probably tell you about himself, but I will give you a profile. Nick was a graduate of the Australian National University, where he studied engineering, and that was in interdisciplinary systems and information technology, software engineering. He grew up playing guitar, and his passion for music and technology led him to work as audio signal processing engineer at Lake Technology in Sydney. You all know Lake. He developed audio enhancement technology for consumer devices. He's now Senior Director at the Consumer Entertainment Technology Group for Dolby Laboratories, who purchased Lake, where he leads teams in Sydney, Beijing and San Francisco. I'm amazed you've got time to come and see us, and I thank you for that. He's been developing technology that brings immersive and enhanced audio experiences to a wide range of consumer devices in the home and on the go. Lots of platforms there. Anyway, I'd like you this evening to welcome Nick, and I'm sure he'll have a lot of interesting things to tell us about. So thank you very much.
Okay, so can you guys hear me at the back? I've just been travelling a bit, so my voice is almost going. So I'll see if I can project throughout this talk. Let me just get this started. Okay. Yeah. So thanks for the introduction today. So today I'm going to be talking about a few aspects of immersive audio, and I'm going to be using Dolby Atmos to talk about some of the history, how some of this progressed from channel-based formats into immersive audio. But I'm really going to spend a bit of time today talking through some things that we don't talk too much about at Dolby. I've spent a lot of my career working on consumer devices. And so at Dolby, what this means for us is, we create technology, predominantly in the form of software, that we then license with our technology partners. And so part of the immersive audio story I'm going to tell today is around some of the challenges we had, what technology needed to be developed, and how do we get complex immersive audio into a mobile phone. So I'm going to talk at the beginning about cinema, and I'm going to talk through where we began in cinema. So this story began in about 2009. It was just after Dolby had started getting 7.1 out into the cinema, and it was where to go next. And so in that kind of context, it was like, well, do we add more channels? Do we add more heights? Do we add height channels? Do we put more channels behind you? What do we do? And you could easily imagine that if we just kept adding speakers to a cinema, we would get into some ridiculous 22.2 kind of layout of some kind of forever escalating numbers game around how many speakers we're putting into a cinema. So the research team in Dolby in San Francisco started to experiment, and they ended up over time actually renting out a few old cinemas and tried a lot of different things. They invited mixers in, and they essentially experimented both with mixers and with what was possible in a cinema at the time. So I'm going to talk through a little bit of the history here, and then I'll have some time for questions at the end. Okay, so this is a very, very quick whirlwind history of cinema audio in one slide. Actually, the last 30 years. This actually is a much longer presentation that probably goes back to 1917 or somewhere along those lines. So the latter part of cinema audio, we were essentially bringing 3 screen channels and a surround channel. So this was in the era of analog film. The formats were around a common surround. So you essentially send the same surround signal to the side speakers and the rear speakers in the cinema. Then in the 1990s, as digital started coming out, the rear side of the speakers in the cinema was split in 2, and that was what was originally a matrix format called Dolby Digital Surround EX. Then towards the end of the 2000 noughts, the cinema format evolved again as the rear of the cinema was split into 4 sections now. So you had a side surround, a rear surround on each side. So this is a basic channel-based cinema. You've got your screen speakers behind the screen, and your 2 left surround and right surround arrays. And so mixing for this is pretty straightforward. It's just a matter of, on your mixing desk, creating a feed for every one of the speakers. So this is how we've been mixing, sound audio for 3 decades now. So that's channel-based. Object-based audio has a bit of a different paradigm. Rather than mixing to a specific speaker channel, the notion is that we place an audio track as an object in the cinema. Then we create some metadata that describes what's happening with the audio essence. In this case, where we have positional information. So there's a bird tweeting, panned, right-hand side, middle of the auditorium. We can do other things with metadata. We can add size. So there are other characteristics of the sound that we can add in at mix time. Diffusion is another characteristic where we can take a sound and spread it. So with an object-based format, you're essentially allowing yourself to not be constrained by a speaker feed and mix audio into a place and then create additional information about how that audio is going to be rendered in the theatre. I put a few examples of some of the metadata that we create when we're doing object-based audio in Dolby Atmos. There are similarities with some of the other immersive formats as well. And you can see here that there are specific metadata that we create that define how the sound is rendered at playback. Now, as I described, channel-based audio is pretty straightforward. There's a lot of history. A lot of people know how to mix it. It's pretty easy to create. It's easy to play back. You send it to the speaker feeds and pan out to the speakers. It's easy to monitor, and you have very direct control over the format. But one of the challenges is that we're limited by the number of channels, right? If you want to create some level of immersion beyond the channels you have, then it's not possible. So I had to put a flat earthers in here, given all the recent flat earth things. So one of the constraints of the common channel-based formats is you're mixing into a 2D plane, so there's no ability to envelop the listener. It's also not really adaptable. You often have to remix. If you want to go for a 7.1 mix, you usually remix that from a 5.1. Even the 2-channel down mixes generally take another authoring pass to verify. So the main difference, the high level from a cinema point of view, is that essentially we're moving the mixing rendering part from, originally it's done at mix time, And then at the playback in an object-based format, we are rendering directly to the speaker positions. Now, when we look at object-based cinema audio, it's inherently scalable. We can start adding speakers, and we'll make use of those speakers as appropriate for playing back that sound in a particular place. So it scales from small playback environments to large playback environments. The challenges are, though, for some complex-based scenes, mixing in object audio may not make sense. If you want to capture a complex sound space with lots of ambience and reverberance, it's hard to represent as an object-based format, so object-based signal. So it's not desirable sometimes to mix that sort of stuff into an object in space. And it's challenging as well, mixing with these formats. They're introducing a lot of new things that a mixer has to worry about. Now, I'm talking at the beginning of this talk predominantly about what happens for cinema mixing. But you can imagine if you start thinking about what it might take for a live sound mixer or someone in a live scenario, they're very, very busy people. It can be challenging to mix, with more channels and more objects and sort of having to worry about panning in a different way. So the solution that a lot of the immersive formats have is we end up with hybrid formats, right? The idea here is that, well, people are familiar with mixing audio into channels, but we also give the flexibility so that you can mix channels, which we call bed-based audio, with surround objects, sound objects, which can be represented as in space. So you end up with these hybrid mixes, and it's quite kind of interesting seeing how people have been creating content over the last 5 years. Dolby Atmos was first out in 2012, and so we've seen about 5 years of mixes. Some of the very early mixes that were being created were essentially very similar to a 5.1 cinematic mix, with the addition of a few interesting objects. And then we've seen people go to town, and it's just basically mixed with the full gamut of objects that are allowed, over 100. And so with these formats, they're all about giving flexibility for somebody that wants to create a mix. And with this creative tool, you can, you do what's appropriate. So I'm going to talk a little bit about what this looks like in a cinema. And so what I've got here is a few diagrams that walk through where we typically locate speakers in a cinema and how Atmos has caused us to make some changes. So this is a typical 5.1 layout that I've represented here. The red speakers at the side and the surrounds are usually paired into two zones, left and right zone. And on the side wall, you typically will see a row of speakers kind of above ear height. When we move to object audio, we're actually able to address every speaker individually, and so this allows for much more directivity of sound. We actually often need less amplification because we're not lighting up an entire array the whole time with sound. You have mixes that will often have bed channels, which is what we call a traditional CHED channel, that will mix sound to one side of the room combined with objects. And so it allows for much more precision placement on the side arrays, but it also allows for better headroom management and gain management as we mix into the side. Another thing that was changed in a typical cinema format is that typically you would have a gap between the screen speakers and the surround speakers. So to be able to pan an object, to pan a sound element from the screen speakers around the room, they've actually added additional speakers to the side so that we have a continuous panning ability to do a continuous pan around the room. The other thing that I thought was worth pointing out was in a cinema, we often typically have had unmatched speakers. So you'd typically put full range screen speakers, so there'd usually be at least 3, often larger in a larger auditorium. And a screen speaker will have a fairly wide response. Surround speakers were typically limited bandwidth. And so one of the changes in developing a new format for the cinema was allowing full bandwidth sound without the need to necessarily bass manage. And so that led to the use of more subwoofers and sort of flexible B chains in the cinema that allowed people to kind of balance the quality of the speakers with the bass with the bass handling and all that sort of stuff, which was fairly fixed for a surround array. And so this is just an overhead view showing rear subs. The purple, which is the addition of the front speakers, and the other thing that was added was height arrays and height speakers. And so in the cinema, we add 2 height arrays, which you can see there as the yellow speakers. And generally, there are these are the bed channel layouts. So when you're creating a mix, you can mix into a stem for individual objects, or you can mix directly into the bed channels. And so you can see there the RTS and LTS are the top arrays on top of the existing beds. Another change that happened in the introduction of the format was typically the sound pressure levels of the rear speakers were actually lower. You would mix to 85 dB SPL for the screen speakers, and the rear speakers were actually pegged at 82. Given that we've added full range speakers and bass management, the whole thing's now uniform. So you have uniform sound pressure levels across the whole auditorium. So this was all sort of happening between 2009 and 2012. 2012 was the first Dolby Atmos title, Brave. And in the lead up to that, there was a lot of experimentation, a lot of talking to people out in industry, and a lot of collaboration with mixers along the way. Before we actually came out with Brave, there were 2 key mixers, which were the early Atmos demo mixers. Incredibles was used mixed at Skywalker, and Avatar. There was a custom mix of Avatar, and these were kind of important activities early in the development of Atmos, because we literally created a dub stage in the middle of a working cinema and worked through with mixers around what their preferences were and how what features they found desirable on the mixing and rendering side. While this was also being developed, there were quite a number of listening tests, and I'm just showing here an example of one of them. So what I'm showing here is a blind subjective test that was done during the development of Atmos to understand how we should place the speakers in the ceiling. And so down the bottom you can see there are an anchor. There's an anchor which is essentially a 3.1. Sorry, a 4.1. It's one mono surround. This is a 5.1. And there were different arrangements of height speakers placed in the cinema, so that so we could do listening tests. These were all configurable. You could turn them on and off for each test. And what we're looking at here is sort of preference tests about where it would be desirable to place the height arrays. You can see there that a single height array was not as desirable. They ended up settling on two arrays in the middle. Here's an example of the effect of 4. They actually tried 3, and it sort of did not score as well as the actual 2. There was some issues with having a center base third array on how they mixed it. So I'm just showing this as one of the many subjective tests that were done during the development of Atmos. And it was very much a format that was created for the cinema by mixers and through a lot of experimentation and testing. So that was 5 years ago. And since then, quite a lot has happened. There's now, the format in the last 5 years, there's now 150 mixing facilities around the world, one in Melbourne. There has been quite an evolution of the mixing tools. I mean, originally, the early mixing tools and the early rendering tools were like essentially hacks to Pro Tools, laid via plugins. I mean, the early rendering, very, very early on, was essentially experimental versions of Atmos. And we used to have a guy sitting in the cinema for every screening for, at least the first 3 months of Brave being screened. So it was very, very much a format that was evolved as we had more feedback. But we fast forwarded to today, and there's 150 cinema mixing facilities that can do full theatre mixes, and the kind of really exciting thing, which I'll talk about a little bit later, is some of the tools now make this very accessible for doing mixing for home and VR and other applications. So there's a downloadable version of Pro Tools with a plugin now that you can actually create Atmos content, which I'll talk a bit about later. Quite a lot's happened on the content side of things. So there's over 700 titles that have been mixed in the last 500 years. Everything from Hollywood content to Bollywood content. Surprising the number of Bollywood movies that have actually been mixed in Atmos. And yeah, so there's been quite some momentum there. There's over 2,800 cinemas in the world that now actually have Atmos playback. And a kind of exciting thing that's happening for us in the cinema is that Dolby has now an offering called Dolby Cinema, where we're actually partnering with theatre companies to have a premium branded theatre that does both Dolby Atmos and high dynamic range vision. And so that's a little bit of the story of where we are now in the cinema. But now I'm going to switch gears and look at what it actually means for immersive audio reaching consumer devices. So for getting Atmos out to an end listener, we'd like to break it up into sort of there's three main stages. There's a content creation stage, distribution, and playback. And whatever type of device we go to or type of content, there's always parallels, but we generally have to do things a little bit differently. And I'll talk about a few of the techniques and different things that we do to make this possible. So, taking this beyond the cinema, we're taking it to a broad range of devices, from TVs all the way through to VR to game consoles. And so I'm going to talk through some of the technical challenges and a few of some of the technology that needed to be invented to make this possible. Okay, so continuing with our creation, delivery, and playback theme, I'm going to talk through a few of these in turn. So I'll touch on content first, and I'll talk through a couple of the workflows. Now, the first thing that we had to do when we looked at what it would mean to take immersive audio to an end consumer was how would we adapt and evolve the cinema format. All right, so the cinema format was created very specifically for mixing in cinemas. Now, we had to add things. We had to extend it, and we had to add it to make it make sense in the home. And so we looked at what it would take from a speaker playback point of view. And this diagram in the middle here, this is the most extreme you can get in a home with Atmos. Right, so there's actually 34 speaker locations possible. We had to pick a number. we thought, Atmos in the cinema, you can drive 64.4 speakers from the Atmos renderer with 128 objects. Actually, it's 118 objects and 9 bed channels and 2 subwoofers. But yeah, so we looked at what would be the maximum thing that would, or at least the maximum combinations of speaker locations. So this diagram in the middle shows where someone might place them. Today, for cost reasons, I think people have a audio visual receiver that goes up to 9.1.6. I think that's about the maximum they do at the moment. But we've had requests for people to go higher. It's kind of crazy what some people do. So that was sort of one of the adaptations. How would it make sense for a home speaker environment? I actually have a whole section of my talk where I'm going to talk about the practicalities of that and what do we do when we don't have 34 speakers or 10 speakers or 12 speakers. But another aspect of what we looked at as well is I spoke about Atmos being a hybrid between channel-based audio and object-based audio. And we also looked into sound field formats. And so I'm not going to go into too much detail today other than this brief introduction, but we looked at this and looked at how an ambisonic format would make sense in the context of Atmos. And so the format itself has what we call intermediate spatial format, which is a hybridized transformation of a higher order B format representation. And what you can see here is, here's our layers, right? One of the differences that we have in our format is that our format is what we call allocentric, which is we render to a room. A lot of the spherical formats are very listener egocentric, and so when we looked at how we would map a room-based system to a sound field-based system, there were some advantages in terms of diversity of where we put the virtual information. Well, not virtual information, but at least the spatial objects themselves. Where would they be placed, and how would that most effectively map to a room-based rendering system? Okay, so I'm going to move off from that now and talk a bit about a couple of the workflows. So this diagram here just gives you a bit of an idea of, at very high level, of what goes into a cinema mix, a home cinema mix. Essentially, it's very, very similar to what we mix in the theatre. The only difference is that they will often take a cinema mix and bring it into a near-field mixing room. And so a near-field mixing room is essentially a high-end home setup where we have 7 speakers on the floor and 4 height speakers and a subwoofer, LFE, fed by an LFE channel. So on the content creation side, there's the mixing happens via a Pro Tools session. We have what we call a rendering mastering unit. And so because you are putting around a lot of audio, these are actually, it's a dedicated box. So it's a dedicated PC box, which pipes MADI from the Pro Tools session into a renderer. It gets used in a cinema context quite heavily, right? They often re-render on a different machine to what you actually mix on. So in most of the cinema mixes, there's actually a dedicated machine, although we do have plug-in based versions now that run on the same Pro Tools session. The whole session creates a .atmos file. We also have another format that we output to, which is a standards-based format, which I'll talk a little bit about later. We do encodes with a number of different tools. Dolby's very much about how do we deliver audio to the end consumer. And so we have a number of different options depending on the type of product and the use case that we render to. QC is always a very big part of episodic and cinematic content workflows. And then we, depending on the output type, we will go out to Blu-ray using TrueHD, or we will create a mix for over-the-top streaming. That's a high-level workflow. Live is a little different. So when we do a live mix, typically we use a lot of different tools. And so I'm not going to go into all the details of the tools. If anyone has any questions or anything like that, I can always follow up later. But there's essentially a live rendering and a live monitoring box. And so they'll typically do this in the context of making a channel-based immersive mix. A lot of what we've been doing so far, in a cinema, you can go to town and create like 118 objects if you want. And believe me, someone has experimented with doing a complex musical mix with that many objects in it. Just the cognitive load for a live sports mixer or a live event mixer is just over the top. So typically what they will do is they will be in a OBI truck outside the venue with a 514 monitoring room. Pretty terrible environments these. They've got cramped speakers above, and so they'll be doing typically a channel-based mixed with some placement of objects. A lot of in the sports context, a lot of the feeds are coming from microphone arrays, and so typically there'll be static placements of a lot of the crowd material. And then they'll take in ball kick submixes and a whole lot of other things that they kind of work through. In the spirit of how I was describing how a lot of this stuff was developed for the cinema, a lot of early live mixing comes out of collaborations for different events. So there was an experimental Atmos broadcast of the Rio 2016 Olympic Games, the open and closing ceremony, and that was a precursor to broader rollouts that we're doing with some of the US cable companies. Where it's really taken off is actually in Europe. They've been doing a lot of mixing for soccer. So right now, every UK Premier League game is mixed in Atmos. And so that took a lot because the games are spread. BT does, I think, about a third of the games, and Sky does the other 2/3. And so it was very successful with BT, and so it took a lot to get that many mixers up and trained. And you can imagine how many games are going on there. So they're all being broadcast in 4K with Dolby Atmos at the moment. So that's the stadium side of things, and then as we sort of play out, there's a whole lot going on once you get into the transmission side of things. So I'm gonna switch gears and talk a little bit about that now. So what I thought I'd focus on for the delivery side of things is kind of the challenge around how the hell do you get that much information about the audio to a TV, right, to an end device. So when we look at 5.1, 5.1 is pretty common. We typically, well, it is not typically, at 48K and 24 bits, you're looking at about 4.8 megabits of information coming out of the console. That's typically transmitted with a codec like Dolby Digital Plus at 192 kilobits per second. So you're looking at about a factor of 23 in compression. Now, with Atmos, it's a bit of a challenge. If we look at the amount of bitrate you would need to transmit the raw PCM, you're looking at over 100 megabits, depending on how complex the mix is. And we're needing to deliver this in existing codecs today. So you're looking at about this example here, where we're sending it in a 384 kilobit DD plus stream. Now, that's an insane amount of compression, right? Over 390 times. A little bit more numbers here. So this is looking at a typical movie. So a typical movie might have a combination of 100 objects and 100 channels. And where peak bit rate over 100 megabits, you would need, more than a Blu-ray. Well, you could fit it on a Blu-ray, but no video. But yeah, you need an incredible amount of data. So if we were to do anything with immersive content in the home, we have to do something very different. It's just not going to work. So one of the inventions that sort of made this possible was a technology we call spatial coding. So is anyone here in this room familiar with games mixing or games audio? Yeah. Okay, so the concepts here are very similar to how a game audio renderer might do occlusion. Right? It's very common for a game to have many sound elements that have to be mixed, and you're limited by the amount of CPU you have, or complexity of the scene. So some of those principles were applied to how would we reduce the amount of information but still make it perceptually equivalent. And so a lot of what we do in data reduction and compression is we're trying to represent the original scene with less information, but have it not perceptible to the end user. So essentially what the technology does is it looks for clusters of objects in similar points in time. Similar in time and space. So closely located objects that are happening in a similar area at a similar point in time get pre-mixed and clustered together. And that's what these spatial clusters are over here. Now, you might think that sounds a bit crazy. We've gone and created a cinema mix. We've used 100 objects or sound elements, and we're clustering them down and mixing them down. But it makes, when you think about the use case, like where we're using this, right? In a cinema, you've got speakers all around you. You want all this diversity in the mix. But in the home environment, we're sending this to 10 speakers, maybe 11 speakers. We might be doing a rendering to headphones. So the diversity of your playback environment allows us to do a dynamic premix beforehand. That's essentially what's going on here. These clusters change over time. So depending on the complexity of the mix, the clusters fade in and out. So it's not a constant mix. And it works surprisingly well. This is how we're putting audio onto Blu-rays and OTT streaming services. So the second part of how do we solve the data problem is we use our audio coding. Now I've put a few of the Dolby codecs here, just to give you a bit of an understanding of how we're doing it here. So Dolby Digital AC3 is our original surround sound format. And then for every other format that we have them for good reasons, we've had to find a way to carry immersive audio with it. Not only have we had to find a way to carry immersive audio, we've had to do it in a backwards compatible way. In terms of the broadcast industry, for example, there's a lot of investment in tools and equipment, and of course we don't want to cause everyone to throw that away or have to mix separately. So a lot of the effort has gone into figuring out how do we make a backwards compatible mix, but then be able to create an immersive version out of the same one. So I'm going to talk about two of these briefly today. I could probably spend another hour talking about Dolby codecs. That's what Dolby does. We do a lot of that. So I'm going to touch briefly on Dolby Digital Plus, which is what we use for streaming today, and Dolby AC4, which is a new next generation audio codec. I've also put on the slide another technology, and another challenge that we came across was it was one thing to get a more immersive audio into the home, but then how do you get it from your TV or your set-top box, cable box, to an audio-visual receiver or a soundbar? And so regular HDMI, great at carrying PCM. So we had to come up with a format to pack decoded PCM with object metadata so that it could flow over HDMI pipes in the home. And that's what that last MAT technology is about. So with Dolby Digital Plus, essentially what we do is we take a base 5.1 mix, and we have a technology called joint object coding, which I'll talk about in a bit more, with information about where these objects should go in the room, and we pack it in a backwards compatible way. So if you have a TV that doesn't understand Atmos, it will just ignore it and it'll get skipped. If it knows about it, it will decode the extra information and create an Atmos mix out of it. So I've gone into a little bit of detail actually in the next couple of slides around how this actually works. So I'm not going inside the codec, I'm sort of going around the base codec. So over on the right-hand side, that's just a regular 5.1 codec. Okay, so we start on the left with our spatially coded mix. So this could have been a movie. We've spatially coded it down to 15 objects. Then what we do is we do two things. We render it, which is essentially mixing it into 5.1, and then we feed that into an encoder, and then we feed the original objects into an encoder. And it's the difference. It's the difference in space and time as upmix parameters, which is sent as metadata. And so that's packed in as additional data into the DD plus stream. And I just remembered my animations. Yeah, sent through. Now, when you, we sort of have two bits of information about what that extra spatial audio is. We have what we call object audio metadata, which is essentially the X, Y, Z, where is that sound in space. And then we have what we call the jock upmix parameters. So this is how do I upmix the audio objects out of the original 5.1 mix. And so this is a spatial parametric coding technique. And then this is packed in into a hidden frame and then sent in the DD plus codec. Now, getting that back out again is pretty straightforward. We take in the bit stream, we rip out the what we call the enhanced metadata data. We do a decode, and then we put it into the audio upmixer, which takes the upmix parameters that we packed in earlier and turns the 5.1 up into 15 channels of audio. And then we do some post-processing on it, and then we output, an Atmos stream. Sounds easy, doesn't it? So that's how we carry Atmos within an existing codec. Now, I'll talk a little bit about AC4 quickly. I've got a bit more detail here than I'll need to go into, but this is not about codecs, so I'm just going to gloss over some of this just to illustrate a few things of how we try to carry immersive audio. So recapping the history a little bit, there's sort of you'll see two things. Whenever you see a Dolby codec, there's kind of a couple of things we talk about. One is the Atsc standard name, which is AC3, EAC3, and AC4. And then this is what we kind of tend to call it out in industry. We gave up on names for AC4, so it's just called AC4. It is what it is. So this is a very advanced codec. It does a lot of different things. I'm just mindful of the time, so I'm not going to step through all of this one by one. Suffice to say that there is a number of coding tools that we use for both compressing spatial information as well as perceptual frequency-based information. The whole codec has been designed to have a kind of flexible output modes. And when we look at this from an immersive audio perspective, we kind of want to make one audio presentation that we can render to a bunch of different scenarios. And so the codec has the notion of an output rendering mode where we can render to an external device outside of the box we're decoding on. We can do simple renders to stereo speakers. We can do what we call virtualization, and I'm going to talk a bit about virtualization in a few minutes in more detail, where we create a virtual immersive presentation. And the way we structure this codec, it actually gives us a few options of whether we do a simple decode for stereo, or we can do more complex decodes for larger numbers of speakers. But that wasn't enough. So when we looked at mobile, we thought, well, how do we keep the information down? Because mobile phones and generally suffer from not having a lot of battery life. So we want to keep computation low when we want to decode audio, and we also want to keep the bit rate down. So another bit of technology that we've developed allows you to take a full immersive Atmos mix. So remember, these are the 128 mixes. We go through a spatial coding phase, and then we can actually send it as a stereo signal. So we can send a low-res signal, and then out of that we can create an immersive headphone presentation. And so that's one way we can get Atmos to reach more places. Now there's a lot that goes into that. We have a way of doing this over headphones, which creates a binaural mix, and we have a way that allows you to take a standard stereo tablet or a phone and create a virtual surround sound thing, and I'll talk about that a little bit more in a second. Okay, so that was talking a bit about how we solved two of the challenges around delivery, spatial coding and audio coding. And I'm going to talk a bit about the playback side of things. So in the home, we can take a device, and that might be connected to audio and audio playback in several different ways. We could be connected to a soundbar or an audio-visual receiver. We could render to headphones or speakers. And in each of these cases, we have to have the ability to have audio flow, whether it's a simple device or something more complex. And so we've developed technology that allows you to do virtual surround sound, as well as on both headphone and speakers. Here's an example of what it might look like in a home environment with some different speaker layouts. Now, one of the things I spoke about before with the advantages of doing an immersive content presentation is that you render at playback time. So no matter how many speakers you put, you actually get the optimal mix for a particular environment. Now, what I've got here is like 4 examples of what typically it looks like in the home today. We've come up with this notation where typically you might say 5.1, and then we add the height channels at the end. So 5.1.2 means 5 on the ear plane, and then 2 overhead speakers. It wasn't practical in all cases for everyone to put speakers above you as well. So one of the other things that people can do is use what we call elevation speakers, which is essentially bouncing the sound off the ceiling. And it works surprisingly well. Again, like spatial coding, some of these things on paper, you talk to an audio purist and you go, really, will that work? And this idea actually came out of an internal hacking competition that we had, where ideas are kind of brought forward. And they used speakers with door stops angled. A door stop actually had the right angle in this particular demo scenario. And there's a small amount of HRTF processing there to kind of give the effect of the overhead shoulder bounce. So the other formats here are, you can see we can add more speakers above, and down here is showing what it looks like with a couple of soundbars. So today you can get soundbars that will just project sound at you and bounce it off the roof. Others have wireless speakers that they connect. So this is one way that we have to render Atmos into the home. But we also had to develop ways of looking into different classes of devices, whether they're PCs, stereo TVs, mobile phones, or even gaming over headphones as an example. So I'm going to shift gears now and get into a little bit of a technical part of my presentation, talking about virtual immersive audio. This is something we've been working on for many years. So speaker virtualization is when we're creating the effect of missing speakers, and we're creating a virtual effect of sound coming from around you or above you, behind you. Headphones are a similar thing, but over headphones. So we've got 2 ears, yet we can hear sound from any direction. or many directions. Generally, we're pretty good at picking sound direction relative to azimuth, elevation, and distance. The two primary cues we use are interaural time difference, which is the difference between time of arrival from your ears, and interaural intensity difference, which is the level between the two ears. Other things include your Pano, and what we call interaural cross-correlation, and the reverberance of the room. So interaural time difference is the difference in a sound's arrival at each ear, and it gives you a strong sense of azimuth. The amplitude difference of a sound at each ear is what we call interaural intensity difference, and this is typically from your head blocking sound from coming around you. Together, ITD and IID are used to determine the arrival and interact differently depending on whether we're talking about low frequencies and high frequencies. Low frequencies, because we're looking at larger wavelengths. The dimension of your head is a sound wave such that there's not a big difference with IID. And at high frequencies, you're kind of more tuned to looking at intensity difference than time difference. However, if we just lose those two measures between your two ears, it's not quite enough for you to figure out where the sound's coming from. You have this cone of confusion where it's ambiguous from your ear's perspective of where the sound is coming from. We call this a cone of confusion. So other things are at play. So the Pano, in other words, your ear, causes sound to do different things as it enters into your ear canal. And there's quite a lot of variation between people on this, as you can imagine. So we capture some of that variation in what we call a head-related transfer function, HRTF. We basically treat the head as a linear system that characterizes the ITD, the IID, and the Pano filtering. And generally we measure them as a function of distance, as azimuth, and elevation. But measuring HRTFs can be tricky. They're a bit of a pain to measure. You typically need a very good place to measure it, and you've got to do a lot of measurements, and people are hard to hold still. So there's a lot of databases of good measured HRTFs. And depending what we're doing when we look at virtual sound sources, we often don't need a full measured HRTF. We can often do a simple spherical head model which captures the ITD and IID. Now, that's not quite enough to capture what's going on when you're listening to sound. We can hear other things about the environment. We can hear the presence, the reverberance in the room. We capture these in what we call a BRIR. It's a binaural room impulse response. And it's a combination of the effect of your head and your physical geometry and the room that you are in. And you thought, great, we could just capture these and then we'll be able to replay a sound back virtually to anyone. But it would be quite difficult to do because, as we know, the world is complex and rooms are very different. So you'd have to do a recording for every single scenario that you wanted to play back. So we tend to break the room impulse into three parts. We break it into a direct path, which is what is the first reflection to hit you. We look at specular reflections, which is the early part of the response. Usually the first reflections. And then we look at the late reflections, which is typically associated with the reverb of the room. It's all the later reflections. And if we look at an impulse response, it looks a little bit like this. And you can see there we've called out the first incident signal. These are the first reflections, and then you can see the late field reverb of the room. And so different rooms will have different impulse responses and different measurements. And so we tend to capture these in terms of a few characteristics. Like the RT60 is an example of the reverberation decay. The direct to late reverb ratio, and the interaural cross-correlation. Now, let's use what we've just learned about how sound hits our head, and maybe we can create a immersive headphone virtualizer. So one way of doing it is to capture a very big long filter called the BRIR, which we spoke about before, and just filter the sound with it. And that would be one way to create a headphone virtualizer. But that's infeasible, as we said before, because rooms are different, and we want to have some ability to efficiently build one of these. So we typically split it into two parts. One we call the anechoic HRTF, which is essentially the direct sound. So this is the very first part of what hits our ears, and then we look at the rest of the room response with that part taken out, and we add them together, and that's how we create a filter to simulate. But then when we actually build one, what we typically do is we pull out the late reverb, and then we often have the short filters in one part. Having the late reverb separate allows us to model this using a reverb, which is generally more efficient if we're going to build one of these things in a consumer device. So the next thing I'm going to look at is how do we do this for two speakers. So generally speaking, we might have two speakers in front of you. You can see in the diagram here. And we want to create the effect of sound coming from different locations. So the problem we have is that we have sound leaking into both ears. So the left speaker here is going to, very small animation. The left speaker here is going to, you can zoom right in there. Zoom in next time. The left speaker in this diagram is going to play the sound into both your left and right ears, which is going to be very difficult if you're trying to create an artificial sound source. So when we do a straight down mix, so this is just taking 5 channels in this diagram and down mixing it to left and right. You can see here we're just gaining and power mixing things in together. And so to start building a speaker virtualizer, we put in some HRTFs to model, the ITD and IODs. But then we also have to add in what we call a crosstalk canceller, which is essentially a cancellation signal so that your right ear doesn't hear the left speaker and vice versa. So we take these techniques and we can take a very complex Atmos scene and we can mix and render it virtually into speakers. And so this scales up from what we have here with the 5.1. And that's how we get Atmos into a whole lot of different devices. So the other thing that I'll talk about briefly before I move on to next steps is a little talk about a few of the relevant standards. So I've only listed a few highlights here. There's actually quite a lot of standards activity in the immersive world, and I'll call out a couple of the key ITU-R standards which are interesting. So this standard BS 2076 has actually been out for a while, and the problem it's trying to solve is how do I store immersive audio? Now that we've got these audio essences and object metadata in a standardized way. And so the RG6 working group of the ITU came together, which has representatives from the BBC, Fraunhofer, Dolby, DTS, a few others that are not off the top of my mind, and standardized a file-based format. Now, this file-based format is actually now being used by Pro Tools, for example, and it will appear in other DAWs and other things over time. It's essentially an Uber format that does everything that everyone wants to do with immersive audio. There are other versions currently being worked on that allow for streaming because this is a file-based format for disk storage, but when we need to do live streaming across different interconnects, there's a need to packetize the object audio metadata in ways that you can't do with a file format. Another effort that's actually been going on for a couple of years is how do we standardize what takes immersive audio and render it in a production environment. And so there's another working group that's looking at standardizing a renderer. And so a number of people in the industry are involved in that. And so the idea there is that there'll be a reference implementation that can play back and produce usable audio out of any ADM file. Which of course will play Dolby Atmos and other formats. There's a number of different activities in SMPTE. Some of them are around interchange formats. In professional workflows, there's often a need to carry over existing AES pipes audio that has additional metadata associated with it. So there's some efforts going on underway to standardize additional metadata in standard ways over standard AES pipes. There's been an on and off effort in SMPTE for, I'm going to say, 3 or 4 years to try to figure out how to standardize cinema. It's been a bit of up and down. I've been sort of watching how this has been pursuing. And so essentially, I think they're in the third round of actually trying to come up with something. And it's essentially based off the Dolby Atmos format with a few extra things. Is I think where they've landed of what it's likely to be. All of the codecs, the emission codecs that the Dolby uses, typically get standardized first in Atsc, which is the European Telecommunication Standards Institute. And there's lots of relevant standards around how we carry the audio. These tend to cover Atmos, because to be able to describe how AC4 has to carry immersive audio, they have to then define how it's going to carry immersive presentation. A couple of other standards worth pointing out are the Atsc, so this is the TV broadcast standard in the US, has elected to use Dolby AC4 as the one and only immersive audio format for North America. So that's a huge rewrite of the standards. It's very complex from a RF point of view all the way through to the audio. I think the audio chapters are like this big compared to everything else. But yeah, that's all been finalized. We've moved past all the ballots on that now. So you'll be seeing and maybe hearing a lot more of that around the world, other places. DVB is also working on next generation audio. And they take a bit of a different approach in Europe. Atsc has historically tried to pick one set of technologies. They actually did something slightly different this time around, in that for audio, they allowed for regional variations. So Atsc 3.0 in North America uses Dolby AC4, but Korea is also another Atsc company. So they've gone with a variant of MPEG-H, Fraunhofer's MPEG-H, which is not the full MPEG-H. It's a low complexity profile that they've picked for that. In Europe, they take a bit of a different approach to standards in audio in general. So they have more of a toolbox approach. So if you want to build a system in a particular country, you have a number of things you can pick from. So they allow a country to choose what technologies they want to use from a broadcast point of view, and then they have to be part of the greater DVB toolbox. And so there's lots of different countries at different places at the moment in Europe of what they're doing with next generation formats and audio. We've been involved in trials in Italy and France. They did some live AC4 trials of the tennis recently. And that's a little bit about standards. So I thought I would wrap up with kind of next steps. Where can I do something with Atmos or immersive audio? So if you haven't experienced yet, probably the lowest hanging fruit is to see a movie at a theatre in Atmos. So I looked it up. There's now 5 cinemas in Melbourne. You can see here I've got the first 4 on the page, but there's a theatre locator. So where are they? Village and Lido and Hoists.
Hoyt's Eastland too, by the way.
Sorry?
Hoyt's Eastland.
Hoyt's Eastland. The thing's out of date. Yeah, they're always building new ones. Yeah, they have. There's 3 event cinemas in Sydney as well that have adopted Atmos. So I didn't see any in Melbourne on the list here. So that's one way to experience Atmos. I was really amazed at the mix for Blade Runner 2049. It's one of the best Atmos mixes I've heard so far. I saw that recently. And it was about the empty space in the mix that they left that made it, I think, special in my point of view. Atmos is out there. You can go into a store and buy an LG TV today that will do Atmos from Netflix and do virtual surround sound over its inbuilt stereo speakers. So that's something my team worked on, so I thought I'd put the picture in the slide. Both on that side of it and that side of it. Another big shift is in the gaming in the PC space. So Windows 10 has Atmos built in. You can stream, you can connect both Windows 10 and Xbox. They actually use the same platform under the hood. So you can connect an Xbox or a Windows PC to an audio-visual receiver. There's over 100 in market now that will play back Atmos and do Atmos that way. But what I'm more excited about is that it now has inbuilt Atmos rendering over headphones. So you can switch it on a Windows PC. So if you want to experience Atmos that way, you can. And there's a number of games coming out. There's 8 games coming out in the next month that all do this. But one new thing that I was pretty impressed with as well is people have started mixing music. And there's been a few albums. Kraftwerk remixed their entire catalogue in Atmos. It was the pet project of one of our engineering VPs in Germany. He was like a kid in a candy shop. He got to go and hang out with his child idols. They've recently done an REM remix of Automatic for the People, which is pretty special. I've only heard it over headphones, and it's pretty cool. Yeah, so there's quite a number of different ways you could listen to Atmos these days. It's not so hard to find, surprisingly. But probably more interesting is, mixing, right? So SoundFirm has a full cinematic mixing and mastering stage. They were one of the early ones. New Zealand beat a lot of people, of course, because of certain Peter Jackson doing movies in New Zealand. But yeah, it's still I think it's still the only full cinematic dub stage. You guys might actually know more.
No, we visited that site.
Yep. So I hear you visited that recently. Yep.
Paper planes they played. Paper planes.
Cool. Yep. But what I think is actually really cool is it's a lot more accessible now. So as of the last major release of Pro Tools, it has built-in Atmos support. Now, what this actually means is a lot about the internal bus structure. So you can't actually mix Atmos out of the box with this version of Pro Tools, but it actually enables you to load an Atmos-enabled session file, and it has all the channel routing and bed structures set up there. So all the 712 cinema beds come online. But then you actually have to add a plugin to it. So there's 2 kinds of plugins, two approaches. The Dolby Atmos mastering suite is actually what you do for cinema mixes and full home cinema mixes. It requires a hardware box that takes MADI audio out of the Pro Tools session, renders it inside that box, and so that's what you would probably put if you were kitting out a pretty good room. But I think the more exciting part for me, at least, is the production suite, because it's entirely software based. It's a downloadable from the Avid store, so you can just spend your $300 and you've got a plugin that allows you to do rendering to speakers, so you can set it up with up to a 714 system. But it's got headphone rendering, so you can actually do headphone monitors as well with virtual surround sound over headphones, which is good for monitoring normal mixes. but also for VR stuff as well. So we've got hooks into VR tools because guys have been doing VR mixes with this as well. Yep.
Headset rendering include tracking on the head?
You need to have a tracker, but it's tracker enabled, right? So yeah, it can take a tracker signal. It actually takes it off the VR headset. Yep. I think there's hooks into that. Yep. Yeah. So just wrapping up. I mean, there's a lot more coming. I mean, we're kind of moving this immersive audio thing away from kind of high end content. We're seeing a lot of it used in live sports. Music is a big thing now. Two types. So we kind of do live events. So this can be a live event captured in immersive sound, and but there's also clubs. So we've actually been doing Atmos mixes in a club environment, and so this essentially has a DJing tool that allows people to create immersive electronic music mixes that plays back in clubs. And there was a recent workshop we did with Ableton, so you can hook it into any kind of production tool that does audio. And so I'll just wrap up there. I think immersive audio is evolving. In the last 5 years, has seen a lot of new technology come out in the market. It's there. I'd like you all to experience it, listen to it, play with it. Yep. It's exciting stuff. So thank you all.
That's great.
Yep.
Questions? We have a question over there, yes.
Yeah, so virtual audio has been out for a while, right? And it's been a great way of having some surround sound without filing for divorce, as some say. But now you're giving it way more rich spatial information than in the past. So how would you compare the virtual audio sound that comes out of an Atmos stream compared to what existed in the past?
Sorry, I missed the first part of what you started your question with.
Virtual audio existed before.
Headphone.
Okay,
right?
sure.
New, but
Yeah,
you're now
yeah.
giving way more spatial information than before.
Yeah.
How would you compare the quality of your product now?
Yeah, well, sure. So you asked, yeah, sure. I can explain that. So I might use like headphones for an example. Okay, so what we used to do with headphones to do virtual surround sound is you'd take like a 5-1 mix, right, and you'd have a virtual sound source, 3 in front, 2 behind. What we're able to do now is, because you've got a 3D sound field, essentially you can have a lot more spatial diversity. So we're actually rendering above, so you have a sense of height, but it allows a lot more granular separation. Examples being, I had a few example mixes recently. It was some guys at work experimenting with some live soccer mixing techniques, and the things you can do with the placement of the crowd and the placement of the commentators that would get a little bit more buried, I guess, in a 5-1 mix. So you just have more information. So you're modeling you can model the world a little bit more realistically, and it just gives a bit more spatial separation.
Okay.
Yeah, no, I was just wondering, my next step was to ask if that would bring virtual audio closer to non-virtual, therefore allowing virtual to go into places that you didn't go before.
Sure. Yeah. I mean,
more and more people are seeing the advantage of having only a sound bar or more lean system instead of having to wire the whole home just to get this surround sound.
Yep. Yeah, it makes it a lot more accessible. Like that's the goal. I mean, you're trying to give more immersive sound experiences to people that, want convenience or cost is more important over that sort of thing. So yeah, absolutely.
I've got a question.
Mm-hmm.
How do you handle the 3D aspects of the production tools? You've got to have a 3D space, and you've got to manage that.
Yep.
How did you tackle that?
Yeah, so you have there's a couple of aspects to it. There's a Pano, right? So there's a 3D Pano, and so we've had 3D Panners. Essentially, you either use a stick or you map it into a 2D space, and so often, there's guys doing sort of joystick mixes with extra things. So there's the kind of placement problem, and I didn't actually put any pictures of the Pano in here, but there's a lot online if you have a look. But I mean, the other aspect, I mean, it gets more complex in a live situation, right? So they had to solve the 3D problem with a lot of legacy gear. So an example is when they were doing the mixes for the Rio Olympic Games. Had to make a lot of 2D buses. So there was actually all these different combinations of submixers that were inherently 2D, but that had to be laid into 3D. So there's ways that you can route audio in a 3D way, I guess, on a low number of channels on existing gear. But yeah.
I'd imagine you're still working on that. Can you tell us which way you're heading?
Yeah, I mean, it's us kind of really working with the console manufacturers a lot. So it's generally like in those mixed scenarios, it's enabling, you know, enough versatility in the console to take those mixes. I mean, we've had mixes. I've had mixes actually do 3D use the 3D panner, you know, with traditional panning pots, right? You kind of do a traditional pan. I mean, essentially that's what Atmos is, right? It's taking a left-right pan and going left-right, back, forwards, and up and down, and that's literally what the algorithm basically is doing under the hood. So you're just kind of extrapolating what you normally do for, you know, a left-right pan, and you know, we work with others that make tools, you know, so we make the software. So yeah, yep.
Okay. Questions?
Yep.
Any plugins for Unity or Unreal Engine to create games that have Atmos content?
Yeah, so we've worked a bit. We've worked a bit with some of the engine guys because essentially you could kind of think of it as two sets of immersive rendering, right? Because you have the game engine doing rendering, and then what we're doing with rendering. So typically we kind of submix. So yeah, so there's a few examples. I mean, we've actually given out example code. We have a Dolby developer portal where we've given example developer code of how to do a pre-render for guys using Weiss, for example. So there's different approaches depending on the engine. Typically, where some are mixing into channel-based, kind of immersive channel-based structures, and then we submix from there. Other guys are playing with ambisonic formats in their game engines. So yeah, it's just a matter of how this fits in. For us on gaming, it's a lot about the rendering, right? It's like when you play back a game, it's about how do you connect it to, you know, an AVR system or a soundbar or, you know, virtual headphones. So it's kind of mapping it into that world is a lot of what we focus on when we think about Atmos in games.
Yes, there's a question down here.
Yep.
In terms of content creation,
yep.
If I understood correctly, there's create content for the cinema, and then the home content is actually two different content creation, or could you automatically convert from one to the other?
Yeah, that's the dream, right? So that's the dream, and I can use the analogy of what some of the studios do. So it's pretty common. I mean, like example is Disney, right? So today, even for like a 5.1. Like they'll remix everything. They're very pedantic about this stuff. So they'll do a Cinema 5.1 mix. They'll do another separate Cinema 7.1 mix. And when they take that to home for a 5.1 mix, they'll go and remix it in a near-field mixing room. Even though you can kind of translate a cinema mix down to 5.1 and stereo. So that's the dream. And we actually have some content, some studios actually literally translating, right? You basically do a QC pass. Because our home tools read the cinema formats and everything, so they kind of can translate it and render it into what we need for home. But some of the studios want to actually customize the mix, so it's kind of a balance. But yeah, the holy grail is mix once and create everywhere. Yeah, I'll chat to you what we do about headphone later. It's interesting. Yeah.
My concern is to send a channel dialogue.
Yep.
Why does it get buried? It can hardly be heard sometimes, even in live cinema. You go to the cinema. I recently saw a film, Victorian Abdul, and I saw it up the Cameo up the hill, and you were struggling to hear the centre channel, a dialogue. Now, is that the setup in the cinema, or is that the mix?
It could be a few things. It could be the room. I mean, one of the challenges with a lot of the cinemas is they'll often be miscalibrated. So there's this kind of loudness war game that some cinemas will go out of reference level because they want to have the blockbuster, you know, that little bit louder. So there can be issues with the room.
saw Dunkirk over
yeah.
at
Yep.
Dolby Atmos over at Eastland, Lloyd's,
Yep.
and that was very good. That was very
Hmm.
good. And you could hear the dialogue.
Yeah, they put a lot.
And the dialogue.
Yeah, yeah. You have to put a lot more effort into calibrating a Dolby Atmos cinema, because if you think about it, you've got a lot more speakers, and you have to make sure they're all working, and they're all calibrated. So just the fact that you have to do that in an immersive cinema means that the tools are a lot better. Like there's a whole cinema setup calibration tool that does proper measurements and all that sort of calibration
There's
stuff.
no real solution to the buried dialogue level.
It's hard to tell. It
You
could,
showed
yeah,
a
yeah,
slide
yeah,
there with all the films
yeah,
you're
yeah,
remixing,
yeah.
Dolby Atmos.
Yep.
Are they going to do something about the center dialogue?
Well, maybe in an Atmos cinema. Maybe in an Atmos cinema. Well, I mean, the other thing is you actually you'll love this. I mean, it's pretty common to historically mix dialogue into the center channel, but often we're mixing it into screen objects now and placing things in different spaces and all that sort of stuff. So that actually should help, right? Because that'll mean when they mix, the dialogue won't all be buried into a single spot. So you have some spatial diversity. You're very good at picking out sounds that come from there and there, so your brain actually has a bit of a better time at
But the old 40s films, 60s films, you could hear the dialogue.
because they're all dialogue. There was no background noise.
He wants to know what's going on. He's supposed to enjoy the flashing light.
They have a bit of a hearing loss. It's like, got to
Yeah.
hear the dialogue.
Anyway,
Anyway, thank you.
no worries. Yeah, it's a hard problem. Yeah. Yeah.
You're talking about about calibration.
Mhm.
So Graham's problem could be a calibration one, or it might be his hearing.
Yep.
But with Atmos, is there going to be some form of certification where Dolby
Yeah,
or
it's
some
kind of
other body is actually certifying this cinema complied on a certain date, or is it purely up to the cinema engineer? to set it up?
Yeah. There's very much a compliance thing.
There was the THX
Yeah.
proposal. You're going down that path, are you?
Yeah. So all the specs were renewed, right? So I was talking a little bit about the fact that all the speakers are full range. There's more flexibility in bass management and the B chain side of cinema. So very very much all the cinemas have a Dolby certification process involved.
Do they get to Australia to check them?
Yeah. We've got a couple of guys here.
Oh, good.
They never come into the Sydney office. They're a mystery to me. I think one of the guys is down here in Soundfirm half his life.
Are you getting much resistance from the cinema owners though about upgrading all their sound? Another standard.
Yeah, it depends. Well, it depends where in the world you are. Like if you're building new cinemas, you go to town on kitting it out with nice new speakers. Australia's a very kind of flat cinema market. We don't build a lot of new cinemas here, and so what we end up having to do is try to make their lives easier. All right. So the whole point is like, what can you do to make a cinema operator's life streamlined? And so when we don't just put Dolby Atmos into a cinema. Like it's about, there's a server, there's all the stuff that automates and the show players and all that sort of side of it as well. So the whole approach is to try to reduce cost. And that's been a really big thing. So you could imagine when Atmos first came out, you would spend, typical cinema would be like $100,000 US, right? And that's because you're kitting it out with 30 or 40 speakers, a rack of amps, the installation costs, you're putting things in the ceiling. So over the years, both our partners in the industry and us have been trying to find ways to make it more cost effective. And we've come up with a number of different things to make it cheaper. Like, for example, installation costs is a real pain. So we came up with a tracking system. So you can lay a track in the ceiling and then feed like a curtain rod all the speakers in from one end, right? And it cuts down installation costs by a certain amount. That's an example. Another example is an amplifier, right? Typically, you'd have a bank of amps this big. Actually, they were over-spec'd in the early specs, right? Too much amplification for what was really going on, erring on the side of caution. And so nobody had done this yet, but there's a 32-channel integrated amplifier that we actually developed. They said this is stupid. Why would you do this? But so you can get like a single 4U rack amplifier that drives 32 speakers, and it power balances across every channel. Because if you think about it, you would drive everybody crazy if you lit up every speaker in a cinema at once. And so that's an example of ways, cost is being looked at, and that makes it easier for cinema guys here. Yeah.
You're doing that through partners.
Well, we're doing a bit of it ourselves. We're doing some of it through partners. We bought a speaker company based in Missouri called SLS, which is just a high-end, not high-end, but sort of a speaker company. And so they've been, so we offer speakers. Dolby's been trying to take the approach that if you can offer something as a full system, it makes everybody's lives easier. So Do-Re-Mi is now it was a company making cinema server boxes, and Dolby purchased Do-Re-Mi a couple of years ago. So now you can actually go to Dolby and we sell you everything if you want. But we still work with others. Yeah.
More questions?
Yep.
Yes.
Own modeling for for virtualization or immersion.
Yep.
It seems the beat link is still the size and the shape of the room, including placement of the speaker, because that needs to be a feedback path given to the modeling system to know how it would be if it's not a standard configuration. So is that a future plan or something which the final user has to take care of by himself?
Yeah, so, it happens in a couple of different ways. Like in a cinema, for example, like our cinema renderers and tools, you can put in exactly where the speakers are and it knows all that stuff. But it was down to sort of practicality in the home in terms of saying, these speakers are good enough. And so, surprisingly, that's quite a lot of options for speakers. And the error that you have in a speaker location, it doesn't matter if you're off by 5 degrees to the effect. It's a pretty robust, stable thing. So that is pretty versatile how it is. However, you can imagine new things we haven't thought of or other people haven't thought of yet. And so the format itself doesn't know about where the speakers are. So if you create this is the beauty of immersive audio. You could create content that knows where it should be in space and time, but the playback could use a different renderer or a different way of playing it back in the future, and you don't have to go and remix the content, right? The content can be the same. Yeah. So so there's examples where we've extended it, or people have been looking at it to do crazy, high-end home theaters where they put speakers all in crazy places beyond what we've thought about. So it's certainly possible.
So there could be products that work over the Dolby Atmos content that optimizes it for the room or something.
Are you talking about equalization for the room?
It's correcting the distortion of
Spatial, yeah.
to match what Dolby was expecting it to be in
Okay.
the ideal room. Kind of thing.
There is tech like that. So there are people that do that kind of room compensation stuff. Like some of the audio visual receivers actually do that today. They'll do full room measurements and do phase and frequency correction and all that sort of stuff to try to and so so the time alignment stuff is a way of simulating whether you've got the speaker in the wrong location and that.
The cinemas tend to try and be dry, so they can lay a render into it, whereas in the home you haven't got that control. People do not want to know about acoustic treatments. They want glass, and polished floors, and hard concrete.
And we even want a soundbar.
Should I go on?
and we're bouncing sound off the roof as well. So. Absolutely. Yeah.
Special part for the bass or the bass management.
The LFE.
There's actually home's different to cinema. Cinema's way different, but absolutely. Yeah, it's managing low frequencies and bass is an important part. So. No, well, it's low frequency, so spatial is not important, but levels are, and you want to avoid clipping and all that sort of stuff. So the renderers typically take bass out and then take it down a different rendering path.
I also saw you had dial norm in those production channels, which you would be using to manage that.
Yes, and it gets very complex when you look at dial norm on 5.1, then Atmos and everything else, but it's still there. Yep. Okay.
Well, I'd really like to thank you for coming along and giving us an excellent overview of all of the immersive audio work that's been going on, particularly with Dolby and their work on Atmos, and a little bit of the future. Certainly like to thank him. And I'm sure you would too, so you can join with me. I'll give him a little encouragement award for doing so well.
Dolby wine.
Thank you.
Yeah, that's right.
Thank you.